The next layer is transport layer. So how many protocols are there in transport layer? How many protocols are there? Let me tell you what we are going to study in this transport layer first. The first thing, UDP. In this, it's services and header. The second thing, TCP. Services, header, handshaking protocol. So this is a brief introduction that we are going to study in this transport layer. The first one will be the UDP, its services and its header. Okay. Now the TCP, its services, its header and handshaking protocols. The last but not the least topic, the routing algorithms. Okay. So let's start with UDP first. Let's start with UDP first. So what kind of protocol is a UDP protocol? What type of protocol is a UDP? The first thing, connectionless, unreliable. It's a connectionless and unreliable protocol. It's a connectionless and unreliable protocol. So why do we use UDP? Why do we use UDP? If it's connectionless, if it's unreliable, then what's the use of using UDP? So in UDP, what is the point? It's connectionless, it's unreliable. If it is so powerless, why we are using UDP? See, the usage of UDP depends when you want to send small messages. Do not care about reliability. Guys, start writing this point. See, whatever you feel that you want to write, just write it on your own. Okay. And whatever I am telling you to write, just write that point also. Because sometimes what happens in the gate questions, they simply ask you directly theory. Okay. Do not care about reliability. Third thing, less overhead. Why less overhead? See, as you know, the OSI model of the transport layer says that the transport layer provides flow control. Again, error control. These things are not provided by the UDP. So now, why less overhead? Because there is no flow control, no error control provided by the UDP. UDP does very less error checking only. Okay, so this is removed from UDP. Now, flow control and error control is not provided by UDP. Then who does provide it? Who provides it for UDP? The upper layer or the services who are using the application or the protocol that are using the services of UDP. It's their responsibility to provide the flow control and error control. Okay, guys. So what is the example? What is the example of a protocol that is using UDP? Example is DNS. Example is DNS. Okay. So now let's move on. Let's see the UDP header. The source port number is 16-bit, 16-bit, 16-bit field, 16-bit field. This all fields are 16-bit. This all fields are 16-bit. Okay. Guys, you know the source port number. What is the source port number? Which uses the source port number? So if an application is sending some request to the client, let's say a client is sending a request to the server, it will write its source port number over here and the destination port number over here. So it's similar to the source IP address and destination IP address. The station who is sending will write its IP address in the source IP address field, and it will write the destination address in the destination address field. Just like the same, the process who is asking for the request or the data, it will write its port number over here and the destination port number over here. Okay, what is this total length field? This total length field defines UDP header plus data. This total length field gets you the UDP header plus data. Okay, this checksum is nothing but a way to check whether the header is correct or not when it receives at the receiver end. So whenever a client will receive a particular packet that is using the UDP services, it will perform a checksum on the header part and it will calculate the value. After calculating the value, it will check whether that checksum which it has calculated is similar to the checksum which is stored in this location. If both the checksums are similar, then it will assume that the particular header and the data is correct. Otherwise, it will discard the packet over there. Okay. Now my question: is this total length field really necessary over here? This is the value of total length field. This is the value of total length field. X is the value of total length field, and it is stored in the total length field of the UDP header. Now, can I find this X value without using the UDP? Without using the UDP services, can I find the value of X? UDP total length field is not necessary, because what it does, what is the rule of transport layer? It will take the data, add the header and send it to the network layer. Now in network layer you will know the IP header has a field known as total length. What is the value of total length? Header plus data. Okay. Now there is another field also, which is what? Header, HLN. This is the value of header. Okay. So if you subtract TL minus HLN, it will give you data part. It will give you data part. This data is nothing but header plus data of the transport layer. So in this case, this data is nothing but this total length value, which is X. So D is equals to X over here. D equals to X. So if total length and header length is given of IP, you can find, and if it is using the services of UDP, you can find the data part or the total length of the UDP header plus data. UDP header length is fixed. It is 8 bytes. Okay, sorry, I forgot, didn't tell you. UDP has a fixed header length which is 8 bytes. This is application layer, transport layer, network layer, data link layer. So what does every layer, what it does? Data plus header. Again it will come to transport layer, it will add its own header. So this is header plus data. This is nothing but this value. Then again it will come to the network layer. Here again it will add header plus data. This header is nothing but this value. This is data. Okay. So now if you want to find the total length of the UDP What is the length of header for UDP? It's 8 bytes. Header length of UDP 8 bytes. It is fixed. The header of the UDP is fixed. It's 8 bytes. Okay. Now, if you see this diagram, in the network layer, what happens? Network layer adds its own header. Network layer adds a header on its own when it comes to the network layer. So, in the network layer, we have a field known as total length. Total length. Bhavnagar, is it clear till now? Now we have another field called header length, hlength, which is described in 4-byte word. Correct? Now, if we want to find out the length of the data, what you do is total length minus hlength. This was the formula, right? This is for IP layer. IP layer. That is the network layer. This was the formula for IP layer. Okay? What is the header? What is the length of header of IP? It's variable. It can be between 20 to 60 bytes. Okay? What is the data part in IP? In network layer. What does the data part contains? Just before that part. Just before the upper layer. If you try to compare it with the transport layer, what does this data part contains? This is transport. This is network. Okay? This is transport layer. This is network layer. I told you guys that each layer adds a header to the data coming from upper layers. So this is the data coming from the upper layer. Okay? What does the transport layer will do? It will add the header. So now the transport layer has added its header. Okay? After that, what it will do? It will send the whole thing to the network layer. Okay? Let's name this whole thing as X. Let's name this whole thing as X. Now this X becomes data for the network layer. So now it has received the data. The value of data is over X. Here. What does the network layer will do? Same as transport layer. Network layer will add its own header. What is the value of X? What is the value of X? X is nothing but H plus D. This is then H plus D. Header plus data. The data part in the network layer comprises of, it contains header plus data of the transport layer. So that's why if you need to find out the total length of UDP, just subtract the total length of IP minus the header length of IP. You will get the data part, which is nothing but the total length of the upper layer.